in DC, we've had a coal tar ban for a little over 10 years, and that was largely motivated by the research and evidence of PAH contamination in our Anacostia watershed. And recently, just in early 2019, we actually amended our coal tar ban to expand it, and that was in kind of different from Wisconsin's experience. That was actually largely motivated by DOE's enforcement team, and are identifying the new ECR products that were being used here in DC during our routine inspections. As I just mentioned, the ban was very recently expanded to include basically banning products that contain ECR, but it also includes a limit on PAH concentrations. So any product with PAH concentrations higher than 0.1% by weight are now banned in the district as well. So violators of the ban are actually subject to a daily fine of $2,500, which can be applied actually retroactively to the last confirmed date of sealant application. So that fine can get pretty hefty should DOE choose to exercise that authority. And, we really saw the passing of this new law, the expansion of this law as really a great accomplishment. And, we're excited about it here in DC. As I sort of mentioned, I want to take a few minutes to briefly discuss the PAH limit specifically in our ban. And the history there. This slide here shows basically the range and averages of PAH concentrations in the 3 different product types that we've been discussing, mainly in this presentation. And when the coal tar ban was first passed over 10 years ago, there really were mainly 2 types of sealants. There were asphalt-based sealants and there were coal tar-based sealants. And these 2 sealant types had significantly different average PAH concentrations. So as you can see here, the average PAH concentration of coal tar is 7%, while it's 0.005% for asphalt, right? So at that time, banning the product type specifically, right, coal tar, was sufficient in eliminating a high pH sealant as a polluting source. The recent addition of ECR products on the market in the last few years makes bans based on material type more complicated. As you can see here, right, this is an estimated range of PAH concentrations for ECR products because, as I said, the same amount of research just isn't there as it is for coal tar and asphalt. As we see here, overlap with coal tar and asphalt, right? They're kind of in the middle there. And that's actually confirmed with several lab analyses that DC did by taking samples of parking lots here in DC that were confirmed to be using the new products. And those lab analyses found pH concentrations ranging from 0.3% to 2.7%, which clearly well overlaps with the coal tar range. So, as we were thinking about it and doing our research, if the pH concentrations in these products, right, are the serious point of concern, right, we're worried about, the pH exposure from these seal coats, why not set a limit on the pHs themselves, right, rather than set a precedent for amending the law every time a new product enters the market, right? That would leave us kind of behind the game. And, we decided, maybe this is actually in the long term, the simplest solution is setting an actual limit on the pH concentrations themselves in these products. So just briefly, right, the question, why 0.1%, right? Why this number? And there's a few key points here. We did a lot of research. We talked to a lot of experts both regulatory research experts, advocates, right? And we landed on the 0.1% by weight limit. And that was primarily because experts that we consulted suggested that 0.1% is sufficient limit in adequately protecting wildlife from harm, but it's not so strict that the limit effectively bans sealants, right? There are many different types of asphalt-based sealants, for example, that are well below the 0.1% limit, right? Their average is 0.005%. We didn't want something that was so strict that was basically a roundabout way of banning sealants. We wanted people and property owners to have an option, but it was also deemed a conservative limit that would protect our residents and our wildlife from harm. There's also, a precedent for legislation that includes that 0.1% limit. The European Union actually classifies road waste with 0.1% pHs or higher as hazardous, and 15 townships in southern Michigan, which Ezra has briefly mentioned, and Tom, I believe, right, currently have a 0.1% pH limit in place as well. So it allows for some, basis and standardizing of regulation, which was important for us, thinking things through in terms of implementation of this new rule. So really quickly, now that we have the legislation passed, right, which was, a success in itself, DOE had to think through how to actually enforce this requirement, which isn't as simple as one would hope, right? Enforcing the ECR components is pretty straightforward because, as I mentioned, right, the CAS numbers on the material, the MSDS, right, clearly identify what is ECR, what is coal tar, what is asphalt, right? The challenge really is the PAH concentration limit. And that is because PAH concentrations in sealant products are not publicly available, right? It's unlikely manufacturers even test for PAH concentrations in their products. And if they do, it is definitely not data that they make public. So fortunately, we have steps we can build off of. There is an EPA standard for testing PAHs, method 8270C, that we could and we do use routinely for lab analyses when we're taking dry sealant samples from properties. So we don't have to start from scratch. But the main issue here is that there's no standard out there for preparing sealant samples in particular for testing. And that sample preparation can actually significantly impact the results of the PAH concentrations. PAH concentrations can differ if you test a wet sample, right, straight out of the bucket, or if you dry a sample, but you dry it for 12 hours versus 24 hours versus 48 hours. You can actually see variations in the pH concentrations based on drying times. And that's primarily, I'm sorry, I'm not showing right. I want to point out this graph here that actually shows, right, as I had mentioned, pHs, the lighter pHs actually volatilize, right, once a sealant has been applied, and a significant number of pHs volatilize within the first 24 to 48 hours of sealant application. So that means technically, right, if one researcher or regulatory agency is testing pH concentrations in a product after 24 hours, they could get a different result from another researcher that's trying the exact same product for 48 hours, or from another researcher that's testing it wet, right? For our purposes, which is really thinking through enforcing and implementing the 0.1% pH limit in our law, since we're testing these products, that these are typically nationally available products, right, for pH concentrations, we wanted to make sure that we're doing this right, that we're testing these products in a way that is replicable and can also be a resource for any other jurisdiction that has passed or is interested in passing pH concentration limits. It can quickly, as I'm sure you can imagine, become confusing both for the regulatory agencies in charge of implementing these laws, as well as the industry itself, right? The industry needs clear guidance on what standards need to be met. So if different cities and states are using different protocols, right, and those are yielding different results, that can lead to a lot of confusion and a lot of really unnecessary duplicative work, right? So while we were thinking this through, we started, sorry, I keep going back and forth, there we go, started consulting other experts that were working on this very question, right? Like Austin, like the Huron River Watershed Council, which has been mentioned, right? Who's done a lot of work pioneering the PAH limit work in this country in particular. And we all agreed that a national standard for testing would really be the most robust approach to implementing this 0.1% PAH limit. DOEE applied for funding through EPA's Chesapeake Bay Program. They have these goal implementation team work groups. So we applied for funding through their toxic contaminants work group, which Greg Allen will actually discuss in just a few minutes. And we basically applied for funding to hire a contractor to develop a protocol for testing PAHs specifically in pavement sealants, and then to actually go ahead and test products with that established protocol to create a publicly available list of products that meet that 0.1% PAH limit. And we were awarded that funding, which we're very grateful for, and the project is actually currently underway. So that contract it's a pretty recent project. It was awarded to a contractor in August of 2019. And the first thing that we did was basically convene a group of regulatory and research experts, as well as environmental stakeholders and advocates, really to help guide the decisions in developing this protocol. We have regulators from Texas, researchers from USGS, right, environmental stakeholders from Michigan, all over to help make this a robust protocol. And right now, we actually have a protocol. We have a QAP, a Quality Assurance Protection Plan, under review at the EPA for the protocol that we put together, and we hope to actually have that approved and to start the testing phase of the protocol in the coming month or so, if we can. And once that protocol has been finalized, then we can actually move on to testing products and developing that low PAH product list, right? That is very exciting for us because we have actually here in DC been holding off on enforcing the PAH limit component of the new law, because as I'm sure you can imagine, right, when we do outreach to prepare a regulated community for a new change, it's really, really important to have very clear guidance, right? And right now, we can't tell them exactly what a low PAH product is, right? Once we have that list, we can actually guide the regulated community and what they can and can't use, what they can and can't sell, right? So we're really excited about this project. We really hope and think it will be a wonderful resource for anybody who chooses to use it, right? And we're making sure that we're thinking through all the nitty-gritty details right now so that you don't necessarily have to if you start to think about legislating or approaching this issue at home, right? So with that, I'd actually like to hand things off to Greg Allen, who I mentioned, who will talk a little bit about how this project fits into the targets and goals of our Chesapeake Bay program.
So the Chesapeake Bay program is a cooperative program among federal agencies that have a mission relationship to Chesapeake Bay. Also, the 6 states plus the District of Columbia, who own portions of the watershed. We also have an amazing assortment of non-government organizations and academics that work with us. The program is directed by an executive council that has members from the jurisdictions and EPA. And that, the program has an executive level goals document that is the 2014 Chesapeake Bay Watershed Agreement. You can, and a series of goals. There's one that is related to toxic contaminants. The goal is to ensure that the bay and its rivers are free of effects from toxics on both living resources and human health. We like to shoot for really big, audacious goals. So that's the goal. And there's an outcome under that goal that basically speaks to continually reducing the amounts of toxic contaminants that come into the system. And for that reason, this project fit with the partnerships, goals, and strategies. We see polyaromatic hydrocarbons everywhere we look for them in the Chesapeake system. They are ubiquitous. Oftentimes, the levels that we detect don't trigger impairments under the Clean Water Act, but sometimes they do. In our urbanized areas, we have very high pH concentrations, and in fact, down in the Elizabeth River, in the Norfolk area, bottom of the bay, are some of the highest bottom concentrations of PAHs known anywhere in the world, because there was a creosote operation there for a long time that directly discharged to the river. So we care about PAHs, and this project fit with our goals and strategies. But I want to be clear that the list that Lillian just mentioned is not an EPA list. This is not going to be an EPA list of approved products by any means. My involvement in the project now is mostly about helping out with the analytical chemistry and some other issues. And so we're providing some technical expertise, but this is not, in the end, an EPA list. It is a District of Columbia list, and the approach and the methods may end up with some other lists being generated elsewhere in the country, or other folks using the list that comes out of DC. So a couple points that we wanted to make there, and I think I'll cut that short so that we have at least a couple minutes to take some questions and answers. I think we are at the key takeaways here. Mm-hmm. So is that Lillian for takeaways?
Sure, yes, thank you. So I know that we definitely want some opportunity for questions here. If you have some time to stay a little bit over, I'm not sure, Carol, if that's allowed or not, but I do want to bring it home here, right? One point that I think is a main takeaway that I hope that we've convinced you here is that Sealcoats are a critical source of pH, or they can be a critical source of pH pollution, and that Sealcoats are used and can be found across the country. From DC's perspective, we also just want you to know that while there are, burgeoning issues and challenges here, like with new products, there's generally just some really exciting breakthroughs and work being done in this field right now, which I hope, we were able to get you excited about as well here today. We are a team of experts. We're collaborating across the country to make sure that we're making really meaningful progress that can be a resource for anyone who chooses to use it, right? This list of low pH products, right, in particular, will be publicly available, right? It can be used to push for legislation in your hometown, city, state, right? But even if legislation isn't necessarily an option, right, it is also just a great resource, right? We've talked a lot about legislation today, but really there's a lot that can be done simply by getting these tools that we've talked about into people's hands and letting people make informed decisions about their property.